Morning, students. Now we will see the new concepts for exercise 7.4. We are going to study some formulas which definitely will be very fruitful and helpful for upcoming exercise and questions. So let's look some formulas first. These are standard formulas. What they are, telling you one by one with derivation. First, suppose you have a condition x square minus a square, and this is a integration. Actually, we are studying some types, and this is as a question. If you want to see that if this question is coming with you, how to solve? Actually, it is a formula, but you have to see and you have to prepare this as a question, because same thing can come in exam. So okay, see this particular as a question as well as a formula, and I will tell you both. As a question, how to deal this, and lastly, whatever we obtain, it will be a formula. Look at the thing. What we will do? It is not under root sign. It is not under root sign. So we will not do substitution. We will do some special. What special here will do? We write x square minus a square as x plus a and x minus a. And then we will separate the denominator in two parts. And this separation called a partial fraction, but I am not telling you the proper method of partial fraction. It is actually in upcoming exercises. It will come in upcoming exercises, but I am telling you that how we can separate the denominator. We have to actually manage the numerator. We have to manage the numerator, and we will use a prediction, just a prediction method. What I'm telling you. Look at. I'll write here x plus a, and I'm writing here x. Suppose it is a minus a, it is a plus a, it is a plus sign. Okay, x plus a. Look at the thing. If you take an LCM, x plus a minus x plus a upon x minus and x plus a. You know x and x is cancelled, and a 2a. So I want to write 2a here. Now can you see that the thing whatever we got, it's a balance. Actually, this is a prediction method. First I wrote x minus a, I use a minus sign and x plus a. I took an LCM, x plus a minus x plus a was coming, meaning in numerator we are having 2a. I balance with dividing 2a. Now if you see whole, this is nothing change. And now you can do simple integration. You know integration of 1 by x minus a, it's just looking like 1 by x. It's a linear function. So 1 by x have integration log x. So it is a log of x minus a. It is same again, log of x plus a. We have done the integration. And I'm not interested to add as an integrating constant, because I'm telling you the formula. When you will have a question, it's good to write C. But right now not. Okay. Now I tell you last thing. Log m minus log n can be written log m by n. Log m by n. And student, you have got the formula as per as a question also. This is I taught you initially two things that I told you initially two things that this is a question as well as it is a formula. When it comes in exam as it is, and you're told to evaluate or find the integration, find the value of integration, you have to do all. Otherwise, you have to use a formula. So I'll tell you later. Okay. Now this is the formula I derived here, and we got a formula that 1 upon x square minus a square is 1 by 2a log of x minus a upon x plus a. And this is very first formula of the day. I will tell you that how question will come and how you can operate this. Okay, some example I am telling you from my side. Suppose that you are told to find the integration I equal to This question is coming front of you. You have to solve this. So definitely you have to compare that this is a none else, but this is the same kind of question. So students, first you will write that x square minus, this is 5, you will write 5 square. Now can you compare? It is x square minus a square. So x square minus a square. Very similar. Very similar. So what you will do? Definitely you will use a formula. You don't have to do all. That's very good thing. Because you already have obtained a very standard formula 1 by 2a. Can you compare? Your a is equal to root 5. So your answer is 1 by 2a. 1 by 2a log of x minus a upon x plus a and plus c. I know that you're pleased here to see this answer. It's within the 2 steps it has over. It has over. This was a derivation, and when question as it is will come in exam, you have to do all. But if this will be coming in exam, you just have to write only 2 steps and get your answer. Okay. So this was from my side only. And let me tell you, without proving, please you do only by your own. That if question comes 1 upon a square minus x square, a square minus x square, or we have a that it was x square minus a square, it is a square minus x square, both of the condition I'm telling you. Suppose this question will come, you have to do the same concept. I tell you, okay, no matter at all, you will write a minus x and a plus x. Then you have definitely to go with separation, like I'm writing a plus x and a minus x. Can you see after taking LCM, a minus x plus a plus x, so x and x will be cancelled, a and a will be 2a, so I balance by dividing 2a. Now it's everything balanced. Don't think that this just do the practice for that. You have to use a prediction method. It is not my practice, that's why I have written very quickly. But you have to look, you will write a minus x here, a plus x here, or something. You will use a plus or minus sign. But let me speak frankly that manage the term like after taking LCM, upside should be 2a remaining. Upside should be remaining 2a, so that it is 2a, and then you have to divide by 2a. Now everything is a balance. Now what to do, student? 1 by 2a. Now you will integrate both of the term. 1 by a plus x will be log of a plus x, and plus it is a 1 upon a minus x will be log of a minus x. But student, keep remember, this was a linear form, and coefficient of x definitely will come in denominator, but it is a 1, so no matter to write 1 here, but it is not 1, it is a minus 1, so coefficient of x is minus 1, I'll write in denominator. That's very, very important thing. Very important thing. And now what to do? 1 by 2a log of a plus x plus and minus minus log of a minus x. What you will do? Log m minus log n will be log m by n. And I don't think that you haven't got it. Actually both are very similar pattern, and the question if will come a square minus x square, constant is coming early before the x square. When x square was coming here before the a square, definitely when this will come, you have to use the law, and when a square minus x square will be coming, you have to go with this. Okay, now I'm not telling you the example because I recently told you the example, because a is a constant value and you have to manage it. Okay, so this is a formula and this is a formula, so keep remember these two formulas. Okay, now let me wrap this, and let me skip on the another one. So next is telling you the formula, which is 1 upon x square plus a square. Okay, what I have taught you? Can you see? 1 upon x square minus a square. This I taught. 1 upon a square minus x square. This I have taught. Now I'm telling you x square plus a square. Try to make the image in your mind that all the formulas is just of 1 upon and 1 upon and 1 upon. And can you compare to these three? It is a minus sign, it is a minus sign, and it is a plus sign. So in case of plus sign, definitely a square plus x square or x square plus a square are same. So I don't think that I need to write both. Both are actually same. But in case of minus sign, both are different. X square minus a square and a square minus x square. And these two already have taught. Now I'm telling you x square plus a square. Look at how to deal this particular problem. How to deal this particular problem. For that only, you put x equal to a tan theta. This will not come in exam. You believe me, it will not come in exam. The derivation will not come in exam. But these two which I taught you very specially, this may come in exam. Please do them. But the rest one, you just have to see that how I got the answer. But finally, you have to keep remember the formula only. So this is x square equal to x equal to a tan theta. This is the substitutor. Till the 7.3 exercise, we used to take t. Every function sin x equal to t or something like that t. Okay, so same I taught, I took here x equal to a tan theta in the form of theta. Don't worry about that. Now, we do differentiation both sides with respect to x, and same will do. Okay, what we'll do? The differentiation of x is 1. We write dx equal to a tan theta have a differentiation sec square theta d theta. That's very simple. Very simple. Now, x have a differentiation 1, then I will write dx, and then a tan theta, what we'll write? We'll write a tan theta have differentiation sec square theta and d theta. Now, what I'll write? Look at, instead of dx, I will write whole, and instead of x, I will write this one. So what will come? 1 upon, so x square equal to, x square meaning a square tan square theta, plus a square, and dx meaning a sec square theta d theta, and then take out a square common, tan square theta plus 1, and it is a sec square theta d theta. What will come? A and a cancel, a will come outside, it's a constant value. 1 upon tan square theta plus 1 is a sec square theta into sec square theta into d theta. Now cancelled, only d theta is remaining. You know integration of d theta is itself theta. So what is the value of theta, student? Search the value of theta from here only. How we can obtain the theta from here? You do transfer a first, meaning x upon a. What it will be coming? X upon a equal to tan theta. So don't you think that theta equal to what? Yes, it is very easy to find the theta, the value of theta. Theta is equal to tan inverse x upon a. So it will be here tan inverse x upon a, and that is a value of 1 upon x square plus a square, and this is again the formula you have got. This is the formula you got, third one. And I just want to tell you one small example so that you can understand easily. So I'm telling you 1 upon, suppose x square plus 9 is here. So what you will write? This is definitely, if question may come 9 plus x square. You should understand between them you have plus sign, so both have the same meaning. So what you will do? You will write x square plus, instead of 9 you will write 3 square. That is very important to write 3 square here. 3 square. Now can you compare? Both questions are same. It is 1 upon x square plus a square. It is 1 upon x square plus 3 square, meaning a equal to 3. Write the formula 1 upon, according to formula, we have answer 1 upon a tan inverse x upon a plus c, and only 2 steps answer you have got. So please keep remember the formulas, otherwise nothing will be happen here in integration. So please do them. Okay, so 3 formulas we have seen till now, and all based off 1 upon what we have seen, 1 upon x square minus a square we have seen, 1 upon a square minus x square we have seen, and 1 upon x square plus a square we have seen. Now we will take some 3 more formulas. Fourth one, I'll say 1 upon over root x square minus a square. Now let's watch 3 formulas I'm telling you, same kind, but with under root sign we will use. So keep remember in the mind that these all formulas are 1 upon without under root. 3 cases are there. Now the upcoming are more 3 formulas, 1 upon all, but with the under root sign. So okay. Now can you see? Do you remember when in integration x square minus a square is coming? You remember in differentiation I taught you the topic substitution method. And in the case of substitution method, I taught you something. When we have something in the square root sign, we have some specific, substitutions we are having. Specific substitutions that we are having. What? Whenever x square minus a square is coming, you have to substitute x equal to a sec theta. This is suppose a square minus x square is coming, you will substitute x equal to a sine theta. When x square plus a square is coming, you have to substitute x equal to a tan theta. So please remember them. These are very specific. One more I taught you, when a plus x and a minus x is coming, you have to go with a cos theta. But this is that, so all four are very, very important substitutor. This all came in the case of differentiation. When I taught you differentiation, then I used this. In case of integration, again these are very important. So don't you think that it is very same? Can you watch here? This is all the substitutor only applicable when the root sign is there. This is only the trick. You know that from the teacher side, it is not specially specified in a book. But keep remember, these are particular substitutor. Whenever the root sign is coming in a question, you can go through this. Okay, so I just wanna tell you that if the integration is coming with same kind x square minus a square, it says put x equal to a sec theta. So I'm putting here, let x equal to a sec theta and do by the same method. Differentiation of x is 1 and then we write dx, and sec theta have a differentiation, sec theta tan theta d theta. Now what will come here? 1 upon, instead of x you will write a sec theta, meaning a square sec square theta minus a square, and dx meaning a sec theta tan theta d theta. What will come? It is a square will common, sec square theta minus 1, a sec theta tan theta d theta. What is coming here? A square will come out as a sec square theta minus 1 is equal to tan square theta, will be written only tan theta, and a sec theta tan theta d theta. A and a cancel, tan and tan cancel, we are having only sec theta. Now what we'll do? I want to rub all because that only I have taught you, and let me rub all because 2 times I have mentioned there with the writing, so that till now you remembered all. Now the final answer will be given, that integration of sec theta, you remember that except the log x, I have taught you all the integrations formula. Now this is the integration of sec theta, it is a log sec theta plus tan theta. You have to remember log sec theta plus tan theta. This is a formula of integration of sec theta. Now what to do next? You have sec theta value is equal to x upon a. You have a value of sec theta x upon a. So put here it is x upon a, but it is not a sec theta. So okay, convert to tan theta in case of in a term of sec theta. So I'll write tan theta equal to sec square theta minus 1 and plus c. So okay, no matter at all, plus c or something like, if you want to remove, okay, no matter, because we are looking formula here. So instead of tan theta I have written sec square theta minus 1, and why I have changed to tan in form of sec theta, because we were having value of sec theta is equal to x upon a. So we wish that everywhere the term sec theta must be there. That's why I've changed to tan theta in the form of sec theta. Okay, so I is equal to log of, instead of sec theta write x upon a, and plus sec square theta, it is x square by a square. Can you see? X square by a square minus 1. And now log of x upon a, take an LCM x square minus a square upon a square will be a. Then after again want to see the LCM, log x square minus a square upon a, and I'm gonna use log m by n, which is log m minus log n. Let me speak frankly that I haven't used here c. You remember that c is a constant. C is a constant. Log a is without x, so it is again whole called constant. So actually we are looking formula so that we ignore this. But when we do the question, we definitely use a c. So this is none else, but it is the part of the constant. So in case of looking the formula, I avoid that because it is a constant value, and ultimately we will use a constant while completing the solution. So that in case of only formula, that is x square minus a square dx, we have log of x plus same. So this is a formula. I have avoided log a because it is a constant and ultimately will be placed there when we do the question. So as far as only formula is concerned, we have seen the formula 1 upon root of x square minus a square equal to log, in mod will be used because there is log there, x plus same. So this is same. So keep remember as I taught you word to word, log x plus same. Okay, now let me rub all, and this is the formula log x plus same. So this is the formula we have seen. Can you see the question? Suppose question is x square minus 16. This is a question. How to do this question? You don't have to do all. You just compare that your question looking like the formula. So you just have to use it now. So how to use this? You write for 16 as 4 square. You write 16 as a 4 square. Now this is looking same. So your formula is log x plus same. Can you catch my words? Can you catch my words? Log x plus same. So okay, I'll write here log x plus same. Same meaning same, and plus c. That only now I'm writing plus c. Okay, and then I avoided log it because it was a part of a c. It's a constant value. This is c now. So your answer have been completed. You can arrange by your wish. Like 16 it is plus c, and that's the answer. So in fourth step we have completed the answer. So what is important? What is important? Important is to just remember the formula, because when we will see all the formulas, the formula will be there. So definitely it is a bit tough to keep remember the formula at the instant. So okay, now we don't want to see once more formula without proving that I'm telling you, and you please accept the formula that x square plus a square, it is suppose the formula is again same, log x plus same, log x plus same. So why? Because very similar proof. What you will do, I'm telling you, I'm just giving you the clue that recently I taught you the proper substitutor. So in case of x square minus a square, what is the proper substitutor? X equal to a sec theta. But x square plus a square, in case the proper substitutor is x equal to a tan theta. And then you will get the same answer. The formula is log x plus same, log x plus same. Keep remember, plus and plus will be same. But log x plus this, definitely it is a plus, it is a plus, it is a minus, it is a minus. So I have written the formula because both are very similar. So okay, I'm leaving that. But the last one I wish to tell you, the last one is 1 upon, it is a square minus x square. This is a formula. You remember that whenever a, in case of under root sign, whenever a square minus x square is coming, what you do? Put x equal to a sine theta. You must remember when you are doing that, in case of under root sign, if you want to do some substitute, if you want to do some substitution, you have to go through this particular that a square minus x square is coming. You have to go with x equal to a sine theta. When x square plus a square is coming here, you have to go through x equal to a tan theta. And for that x square minus a square, you will replace the value of x by a sec theta. Okay. So x equal to a sine theta, you do the differentiation. Sine theta have a differentiation cos theta d theta, and go with that a square minus x square will be a square sine square theta, and dx will be a cos theta d theta. Now 1 upon a square will be coming out. Answer is 1 minus sine square theta and a cos theta d theta. Now 1 upon a square is written a 1 minus sine square theta is a cos square theta, meaning cos theta, and here it is a cos theta d theta, a cos theta d theta. Cos and cos cancel, a and a cancel, so you have just theta and the answer is theta plus c. So I don't write theta plus c, it's a constant value. So what is theta? Look at theta is equal to x upon a, and sine is equal to sine theta, so theta is equal to sine inverse x by a. So sine inverse x upon a, you have seen the formula that a square minus x square dx is equal to none else but sine inverse x by a. This is a formula. Okay, this is a formula. So till now you have seen what kind of formula is there. 6 formulas I have taught you. Two things more I want to tell you. And you have to see it. Okay, let me tell you once more, and let me rub it all now. You remember that dy dx of sine inverse x is equal to 1 upon 1 minus x square. So in case of integration I taught you the formulas that 1 upon 1 minus x square dx was sine inverse x. You remember, you must. And dy dx of tan inverse x I taught you 1 upon 1 plus x square. So in case of 1 plus x square, you have answer tan inverse x. Initially these two I taught you. Once more I want to write dy dx of sec inverse x have a formula 1 upon x into x square minus 1. So integration of 1 upon x into x square minus 1 have an integration sec inverse x. Okay. So student, now what I wanted to tell you, look at. Recently I taught you the formula a square minus x square. This is a formula sine inverse x by a. It's very correct. Recently we have seen. You can see the video and you can rewind it and you can see that 1 upon a square minus x square. We have seen recently this formula. What I want to tell you. Can you put a equal to 1? Can you put a equal to 1? What will be coming? 1 minus x square. What is coming here? Sine inverse x upon 1. Would you think that we have already seen the formula? 1 upon 1 minus x square dx equal to sine inverse x. Already we have seen the formula. So what I want to say that when 1 is coming there now, you just don't have to afraid. You don't have to follow the formula. It should be in a very quick practice that whenever 1 is coming here, 1 minus x square, you can write sine inverse x. Sine inverse x. You need not write 1 square, you need not write compare with a square minus x square, something like that. It should be in your practice that whenever 1 minus x square is coming, write at the instant sine inverse x. But when instead of 1, some 2 or 3 or 4 is coming, definitely you have to make the condition and use a formula. Okay, similar 1 upon x square plus a square. We have seen the formula recently 1 upon a tan inverse x by a. I want to speak one thing, and it's a request and suggestion also. Please copy all the formulas in single paper. Please note all the formulas on single paper. Keep always front of you while doing the question. It will definitely help you. Whatever the question you are making, use the take the help of the paper, take the help of the notes of the formula and do them. And slowly formula will definitely come in your mind. Okay. So this formula we have seen. Can you see a equal to 1? So your answer is x square plus 1 or 1 plus x square, whatever you can say. So answer is 1 by 1 tan inverse x by 1. So 1 I don't want to write. This is the same. 1 upon 1 plus x square. So again I want to repeat same sentence. Whenever 1 upon 1 plus x square is coming, you have to write directly tan inverse x. Please don't manage like 1 square plus x square. Please don't try to compare with x square plus a square and something like that. It's a silly thing. So if 1 plus x square is coming, please go through tan inverse x. If in root 1 minus x square is coming, go through sin inverse x. So it's a practice thing, student. Otherwise you will definitely get confused. Okay. So let me wrap this all now. And students, final formula I want to discuss, 1 upon x into x square minus a square. This is a formula. Last formula. This is actually it will come very rare, very rare. It will not come often in the questions, but you have to remember that for that only you put x equal to, remember x square minus a square coming in the under root sign, you put x equal to a sec theta and go on. Dx equal to a sec theta tan theta d theta, and then I equal to 1 upon, instead of x you will put a sec theta, x square meaning a sec square theta minus a square, dx will be a sec theta tan theta d theta. Now a and a cancel, sec and sec cancel, 1 upon a square, it was a square because x square it was, so a square sec square theta, a square take out common, so remaining is sec square theta minus 1 and it is tan theta d theta. Definitely a square will be a sec square theta minus 1 equal to tan square theta will be tan theta, and again tan theta, and d theta, tan and tan cancel, 1 by constant, integration of d theta will be theta only. So your answer 1 upon x into x square minus a square dx equal to, you can see that answer is 1 by a, and instead of theta put a value from theta. What do you think that? X upon a equal to sec theta, so theta will be sec inverse x by a. What it is? Sec inverse x by a, and that's answer. So again I would say same, when a equal to 1, what it will be? X square minus 1, that only I have seen the formula sec inverse x. This already we have seen, 1 upon 1 sec inverse x upon 1. So this is the formula already we have seen. Differentiation of sec inverse x equal to 1 upon x into x square minus 1. So integration of 1 upon x into x square minus 1 equal to this one. Now this is particular for a equal to 1. So whenever this will come, don't compare with this and write answer. But instead of 1, some 2, 3 coming, you have to compare with this formula. Okay. So I think it's enough of the day, of the lecture, because 7 important formulas we have explained, we have seen here. And from the next lecture, we will see the questions. Thank you.